So hi, I'm Leo from Graphistry. You are hopefully in the right room. So we're talking about breaking Splunk boss of the SOC, where we're using AI to speedrun CTFs. And so we are in the right room, so there's that. And do you want to say, so thank you first of all for the patience as we figured out, and also for inviting me to be here. And I'll be talking about things, but in reality, this type of work takes a team. And so there are other folks I want to just call out, like Alex Maurice, Alex Warren, Tan Moy, Sindra, Thomas Cook. You'll see slides later, but yeah, this work does take a few folks over time. And I guess what we're going to get set up, I'm guessing most people have not necessarily heard of Graphistry, our team. But there's a good chance you've used technology we've built. We've done a lot of open source and free stuff over the last decade. So for example, you might be familiar with Apache Arrow or NVIDIA Rapids, where you can do things on GPUs a lot easier nowadays. So we helped a lot of that happen. Oh my gosh, this is so much better now. Thank you.
Yeah, but you'll have to sit over here because I don't have my clicker.
Awesome, thank you.
So,
thank you, Kat.
I'm staying here because I don't trust people with my laptop.
Great. And can we... I don't know if I can get rid of this thing. It's okay. All right. So yeah, so I'll park over here. But just like really briefly, just check out some of that stuff. Also, I do want to call out, we have a one-day annual AI security event. So if you like this kind of stuff, there's a lot of great talks today. If you want more of it, we're doing it on both virtual, and if you're RSA, we have a full one-day event. It's free. It's a lot of fun. So I highly encourage. And this year we're doing trainings. So actually, quick question. Who here has ever done a CTF, red team, blue team? All right, cool. We're in the right room. So thank you. So something funny started happening in the last year or so, which is there's this weird like pro-human, anti-AI thing going on. And I understand it for many reasons, but one of the more funny ones is, and this is actually a bit more for empathy, is like, imagine you're the organizer and you're trying to figure out what's the way to do a good community thing here. And originally I wanted to show a live version of this, but just in the interest of time, I don't want to go for it. But what you see here is like last year, at the beginning of last year, we published a video that went viral that kind of showed us taking Splunk's boss of the SOC and basically solving 3/4 of it. And all that's going on in this one is we basically took each question, a little generic prompt that we use across all of them. And then the AI, it wasn't just like ChatGPT answering a question, but it's like modern agentic, where it actually called tools, like it went through it. And the video showed not just doing one question, but all the questions in parallel. And so if you're organizing a CTF and then somebody shows up with one of these things, that's kind of frustrating. You're kind of like, what are we doing here? Yeah, we have the videos online, you could find it. But like, I think maybe for where we were about published last year, so the work of about 2 years ago, to be honest, is 3/4 of it was solved. So instead of a team taking an entire day, the AI would spend about 2 hours. And each question, even the hard ones, was just 2 or 3 minutes. And that was sort of, yeah. But that's not what this talk is about, because that's the stuff from a couple of years ago. And honestly, that was a C-, like if you just think about like where we are. And so what I want to talk about today is a few things. First one is, why are we doing this? Why are we attacking these competitions? And for that, and the broad goal is, like, as a defender, we want to bring AI into our practice, and we want AIs to investigate. And if you think at a communal level, imagine everybody had like Bruce Schneier in their pocket. So the next time a relative is getting phished, what if like Bruce Schneier was helping them? That would be pretty amazing. So to get there, if you're doing AI, where AI learns is an AI gym. And so these CTFs are actually pretty incredible, because some of the smartest security people in the world have been spending years honing these things. And that is the perfect learning environment. Thank you. Oh, maybe you did not want to press that button. Okay, so that these AI gyms are pretty useful as an AI person. But then at a more human level, we like to play. Like, play is a way how you learn. That's like a safe place that you can actually just run as fast as you can, see what works, see what doesn't. So as individuals, and like if you want to do it yourself, and that's going to be a big focus for the first half of the talk, we need places to play, and we need everyone to be able to play. And I think CTFs before AI, that was true. And now with AI, I think that's even more true. And so we're going to talk about that. And then we'll talk a little bit about as a more, my background's actually more of a scientist, and this is actually, we also like to play just like in slightly different ways or as an engineer. So we'll talk about that. And so what I want to go through today for the first half is a bit about benchmarking AI evals, and then a bit about how I think basically, honestly, if after you have fun today and tomorrow, maybe spend Sunday trying to recreate some of this. And that's the first half of the talk. And then the last bit, if you are doing this a little more professionally, how do we get an A plus? What's then like, where's this going? I'm not going to press the button this time. Okay. So I too am learning. Okay. Okay, so just for a bit of a framing of, you'll see AI people talk about benchmarks and evals a lot. First one is, I like this quote from Lord Kelvin, so of fame of the Kelvin scale, named after him. If you cannot measure it, you cannot improve it. And so as we're trying to methodically go these things, we need a way to have steady progress. If you've seen a lot of vibe coded projects, they're exciting for the vibes phase. In evals, that's how you start. You just kind of, but then once you get things rolling, you do need to switch to something more engineered and methodical. So you need to have a way to measure AI investigations. But then there's a kind of a dark side. And so we flip it and you get what you measure. So Goodhart's law. And this is a nice way of saying it is like, it's about communal values. By someone putting out a benchmark of this is what we think is important, then the various teams could kind of rally and say, hey, this is a thing to beat, this is the system to hack, this is the problem to solve. People who don't do that or come up with their own benchmark, things like that, that's actually a little dangerous, because all of a sudden they're making their own tests, grading their own homework. And as an industry, one of the things I love about CTFs is we're not defining the benchmark. These are community defined benchmarks. And I really love that. And then I don't know if it comes out, but there's a gentleman, maybe a little less famous, holding up 2 lobsters on a boat on the right, Cinder Beta. He said this more in a detection engineering context, but internally, the way we think about, if you can't reproduce it, did it even happen? And so like what does it mean to have a real result? Internally, we have a less pretty version of this, which is evals or GTFO, that increasingly when I see results, that's kind of how we talk about them. So, and just to kind of give you like a simplified model of how important this is. Let's say you use the AI coding tool, do the stuff I talk about for the first half, and you get a C minus. I think that's great. That's where you want to start. But then if you want to start like using these for real and like put it into production, let's say we get a C minus on every task. We get a C minus. A real investigation, let's say 10 things have to go right. So doesn't matter what order, but those 10 facts, we have to be sure we can't miss them and we have to hit them. If I have that, my AI coin and with a 70% hit rate, and I need to get those 10 things right, I'm only going to have a 3% chance of that investigation working. And imagine if I'm fully automated. That means like, who's going to use an automation like that? That's terrible. Now, let's say I improve my coin. I go from like, I'm trying to get to 100%. So I do all the effort to half the distance to 100%. So I improve my coin to 85%, 90%, 95%. I keep improving my coin. And I put the same amount of effort each time. It gets harder to make less progress, right? I'm still at 59% on my 10 things holding my case together. So that's still an unreliable tool. Okay, I go 95, 98, 99, 99.5. I think I dropped a number. So 99.75, 90, I keep doing that. I'm now finally at that 99% confidence. And that's just for doing 10 steps. So that's going to be a lot of the folks in the second half is like, and part of it is, think of the C minus. That's not bad. It just means we're at the beginning. We're not at the end. And maybe actually one more, just I think because we are humans in the office, I don't think we have any AIs in the audience. I think this also tells you why human in the loop is so important. Because an AI, let's say, takes 10 steps with 99% or like 90% or 50, wherever it's at. If you have a human in the loop, well, they can take another 10 steps and another 10 steps. And maybe we get it to 100 steps or 1,000 steps. So I think human in the loop, I call it vibes investigating. I'm actually very bullish on that for doing deeper progress. So reason, I didn't really go too deep in the example just because of time and the setup. But the reason I like bots as a CTF specifically, and I encourage you, if you want to start here, a few things. One, it is free and open. And so as a scientist, that's sort of like, you can't have closed gates and call this a community thing. Second is the example of in the beginning that, if you see the slides after, was doing some sort of a cloud incident, some S3 like incident startup thing. Underneath, that required like scoping, like what happened, what was the timeline? Like all these things take time and are hard. And so even though individual questions are like whatever, from characterizing what an actual incident response does, like at like a tier 2 level, that's pretty good stuff. And it's not just the cloud logs, they'll actually have the same incident over multiple log types. Like, oh, we'll actually have both the cloud version, but also the person doing it will have their Windows security logs on their device. So we'll have overlapping multi-source data sets. So this is, I actually hats off to the boss of the SOC team. They actually did a really good job. So the rules for the game, it's kind of like the CTF, but we want to change things to make them a little more interesting. So, and I want to talk about 2 points. One is we're not going to do the OpenAI trick of like, it's not like the Math Olympiad where I'm going to spend $10,000 to answer 2 questions. Like I can't do every single ticket that comes into an inbox with $10,000 for 5 minutes. Like that doesn't work. So um, for this one, we're just going to talk about time. When we did it last year, it was 5 minutes. I actually should update the slide to say 3 minutes. That's probably a more interesting thing for us nowadays. Also, I probably want to switch it from time to actually dollars. Like what's the token burn? The second thing that was kind of fun was something called contamination. And so we know these all the AI model people are just training basically on the internet. They're training as much as they can, all the data they can. Every new model has more data. And so one of the first things we do when we try a new model is we actually run it on the CTF, but we don't actually connect it to the database. So it's like, how could it do on a CTF just with what it knows and just guessing answers? And it doesn't get a 0. None of them get a 0, which is kind of funny. So we looked at it. A few of the questions is actually, it's just like knowledge base. Like the first one's like a freebie, like just does it can it read? Like for Splunk, it's like, what is the name of this tool? Oh, it's probably Splunk. It's just common knowledge. Some of them are actually the way we run a AI CTF is a little different from how you run a human CTF. In a human CTF, you have a list of questions in the team. It's like a puzzle hunt. You kind of work through it. In an AI CTF, that's really boring if you're just going one question at a time. We really want to run all of them. And so we actually run all of them, but some of them are sort of path dependent, where one question unlocks the next one. And so we actually inline some of those answers. And what we hadn't realized is actually sometimes those answers of the previous question you don't even have to do anything in the next one. It's like it's fully answerable. And so there's a bit of that too. So, but what it told us is the AI companies are trying to cheat, but the models are not actually, these are still valid CTAs, but you got to do the work to be sure. Every new model, we have to do it. So, okay, first result, we're going to do the simplest and most dumb thing to do. And so imagine I'm actually showing here, it's probably invisible with the red and the black in the screen, but on the bottom, it's basically, we're calling Claude Code. We're connecting it to Splunk, and we're not even, no MCPs or anything. We're just, we're just going like caveman. We're just like, you have the CLI, figure it out. Here's your credentials. And it actually does pretty good. So, and it was actually, as a team building tools here, it did depressingly good. So like it was a fail, but it's a really impressive failure. So Opus 4.5. So we ran this a couple months ago. We don't have 4.6 yet. It's not enabled and fully available, but so we weren't able to run it. But it got a 56%. That's still below where we were a year ago, but with no prompt engineering. Just like you saw that was the prompt. I thought that was ridiculous and amazing in an amazing way. And then as curiosity, we ran Sonnet 4.5. So this thing is much cheaper, and it got still failing 30%. But that's actually a very interesting number for two reasons. One is that means we could do prompt engineering to get more mileage out of it. And that means if I want to have a lot of cheapo tickets, which I don't want to spend a really pricey model on, there's actually a lot of good we can get out of these. And then the second is, does anyone here run their own models? So we got a few people. Yeah. The top open source models are kind of roughly where Sonnet is. And so that means take the Sonnet raw score, add your prompt engineering, and you can probably get a C-. And if you're into that, let's talk after. So to me, that was also very encouraging. So let's talk about prompting. Some of the prompting you actually don't even have to do. The stuff we did in the first Word version, like plans with to-do lists and all that, but AI actually does now. So like a big chunk of our initial prompt just went away. So to-do lists, check them out. They're automatically happening. You'll see them automated. But we did two things we found was pretty impactful. Was thinking about around planning was methodology and validation. And this is a good example of where AI investigating is very different from AI coding. So in AI coding, you might have a specification that you're kind of doing. This is what it means to good software. Here's your feature list. And then you might have unit tests to make sure it kind of does the right thing. And then you go into Ralph mode, where if it doesn't, you just ask it to run again and keep running and running until all the unit tests pass. In security, we do not have unit tests. We don't even know if it's a real hack or not. Sometimes you'll never know, right? Like you're not going to go like all FBI on it. So we do two things. One is there's a lot of different methodologies. I'm not going to get religious on this. Two popular ones are UDA and Oscar. A crazy thing with LLMs is I don't have to explain what they are. The LLMs knows what they are, so you just have to tell them to use them. And then a lot of the important parts in terms of investigation, that just kind of takes care of it. You can tweak it more, but just starting there, so again, you can fit full prompts on the slide, right? So that's kind of intuitive. We need an investigative methodology because it's not coding. And the other part is, this was less obvious to me, was we need cross-validation. So the simple version is let's say the LLM does bad and you're like, well, I want it to do better. And you could just intuitively ask, hey, LLM, do better, or maybe not do better, but be more certain. And then maybe it'll figure out what it means to be more certain and it'll do it. That's a good intuition, and cross-validation is just sort of formalization of that. And so, for example, if you're looking at a real incident, if something happened in one log source in one event and it's real, there should be an overlapping alternate log source that corroborates that behavior at the same time. Or maybe it's in that same initial one, but it's kind of phrased a little differently. And so cross-validation is a way to kind of help fight hallucination, to actually force that in. And so that was, you kind of see in the bottom right, we have very short prompt on that. But that, when you see a 10 or 20% lift on something very simple like that, that's the kind of wins you get in the beginning when we're at this C- phase. So I thought that was really cool. I'll be sharing all these prompts. I don't know if the slides go public, but I'll share all the prompts on Twitter and LinkedIn. So again, they fit on slides, but I'll try to wrap them up. Okay, so this kind of stuff gets you to a C- fast. And again, a year ago, it would have been really hard, but now just try it. Do it for yourself. But now we have to start working for our gains. One of my favorite quotes is from the beginning of Anna Karenina: "All happy families are alike. Each unhappy family is unhappy in its own way." And if anyone deals with data and databases, this should feel a little familiar. Yes, it's SQL. Yes, it's Splunk. Yes, it's Cousteau. But every team has different tables, and when it's logs, what's in those tables are also very different. And this is really hard on the AI. The first hope is you could go to a vendor and they just solve it for you. So Splunk, we're boss of the stock is Splunk, but everyone like Cousteau and everybody else has their own. But generally, there's something I call a thin MCP. So an MCP, if you're not familiar, is basically a wrapper around ideas like REST and APIs, so that the AI can more easily talk to whatever the tool is, in this case, a database. A thin MCP to me is just a wrapper. It's just telling you how to call it. We actually do see a benefit from MCPs just by the fact of going from curl to MCP. And the intuition is a little funny, which is basically when it has to figure out curl, it has to figure out the right song and dance to call the underlying REST API correctly. So we burn a lot of our time at the AI figuring that out. By having the MCP, you can kind of skip the ceremony. And because we're in a cost and time gated activity, that's actually a big deal. So an MCP helps. But at the same time, Splunk and most of these are a thin MCP. So in Splunk, from an AI perspective, it doesn't really give us a map of how to work with the data. So what would a map mean? Well, I want to know Splunk will tell you which indexes are, but it won't tell you which log sources or which tables are in each index. For each log source, it won't tell you which columns are in there. For each column, let's say there's a column like host. Well, host can mean so many different things and across so many different sources. How do you jump across and pivot across? It doesn't give you a map or data dictionary or anything like that. And this can go very deep. So adding that helps in. One more that for folks, anyone vibe code? Okay, awesome. Anyone, when you do a loop, you do unit tests, right? Does anybody have the unit tests in the loop that's actually not a unit test, but a performance benchmark? No hands. Okay. So we had some hands for tests, but no hands for benchmarks. So in our world, if we're trying to actually go up the leaderboard, we want to have, we're making our investigator the Python code for all of our custom tools, but actually our prompts, our skills, all of those are part of our eval sets. And so when we do AI coding loops, we're not trying to pass the unit tests. We're trying to do an error analysis of what went wrong. Are we wasting tokens? Are we getting questions wrong? And we're actually building out and on optimizing our eval set. So I don't really call it vibe coding anymore. I call it more eval-driven coding loops, because it's a very different mentality once you start thinking about not just passing, but doing well. As a trick for the at-home thing, one of the most useful things we did here about maybe half a year ago is we use open telemetry. So all the logs, but actually not just the logs, but the prompts, all of that, the AI gets the feedback on itself. And then in the last few months, both OpenAI and Claude exposed that as well. So you can actually do that at home as well now. You might not write your own tools, but you're probably writing your own prompts. And this is a very different way of thinking about it. One more thing I want to share here was kind of fun was we started thinking about the problem differently now. Before it was just a very, cold start. You have a question and you answer it. And with each question we answered independently. In a real scenario, like we're curious, like, if you actually look how somebody does a competition, they spin up the database, they took a look at what's in there, they start figuring things out. We wonder, like, what if we actually have the AI jump in? It does that, but not only does that, but it goes full IR mode. It's like, does a full C-circ flow of like it, even not knowing what the incidents are, it figures out what the incidents are, creates a bunch of timelines, creates a bunch of IR reports. We actually had to create graphs, visualizations, mapping them all out. It spends time without any, it does the competition without any questions. Just like, think of that. It just has a database and it investigates. And then now it has a crib sheet and now it investigates. And then what we get, is all of a sudden, this is a result from this week, we are now at 100%. So this is, it's not like we're beating it, we killed it. Like, this thing is dead. And then also a note is, because we did that, our solve time for each question is now cut in half, because it still has to investigate more, but it just knows so much about what's going on that is kind of like burned in and ready to go. So to me, we're still figuring out all the ramifications of this, but it's changing how we think about a lot of it. So with that, just couple wrapping it together. Hopefully you have a bit of confidence here that a lot of people here are using vibe coding tools. Just go to GitHub, get your favorite CTF, get your favorite MCP, and just try it. See how far you can get. Try some of the tricks I gave here, like see if you can go from like an F to a C-, and then iterate from there. We're trying to make this easier. And so we're also trying to make it, again, like, how do we get this in everyone's pocket? So you have the CSIRT team in your pocket always available. We're getting ready to release that stuff for free. For now, we're giving out privately for free. So sign up on the website, tell us what database you have, and we'll get you early access to the free version. And just bring your own keys. We don't like all private AI. The other one, just at a conceptual, I just want to go back to the beginning on benchmarks. Hopefully you're seeing why I care so much about CTFs, benchmarks. It's kind of adding up a bit more, like this is the core of how the community needs to work. I think my recommendation for the CTF community is don't ban AI, just make an AI track. People need to learn that stuff anyway. And it's actually our chance to shape where the industry goes, because we get to say what we believe is important. And with that, I just want to say, thank you.